Welcome back, Math 10. Today we're going to learn how to calculate the measure of an angle in a right triangle. Now in previous classes, we've learned how to calculate the side, given an angle and a side, and we also learned about our ratios, our trig ratios. We know that sine is the ratio of our opposite divided by our hypotenuse. We know cosine is the ratio of our adjacent divided by hypotenuse, and we also know that tangent is the ratio of our opposite divided by our adjacent. And the way we remember that is SOHCAHTOA. Right? So no matter what right angle triangle it is, if the angle's the same, our opposite and hypotenuse will be the same ratio. So right here we're looking at sine x. Okay? It says, now try and solve for x. So how do I do that? Well, I gave a hint. It's not quite true why it works, but it helps you understand it maybe in some ways. It says, let's pretend that sine is a variable and we're trying to isolate for x. Okay? So let's go back here. And we want to pretend that sine is a variable and we isolate from x. So I'm going to divide both sides by sine. Okay? So now I'm going to get x is equal to 0.5 sine. Well, what is this in exponent form? If I want that on top, that's going to be sine to the negative 1, 0.5. Okay? So that's one way to think about it. In reality, we want to do the integral form. Okay? Or sorry, the inverse. So in reality, we want to do the inverse of this. So I really have here, we're saying sine x is equal to 0.5. Now I want to have this inside there instead of the x inside of there, right? Because I want to do this. But if I do that, this isn't my angle. So we're doing the inverse, the opposite function. So the opposite of multiplying is dividing. When we divide, that's like to the negative 1. So instead, that's the opposite function, right? So just like the opposite of addition and subtraction. So here we're going to do the opposite. So we're going to have x is equal to sine, the inverse sine of 0.5. So we're going to kind of do the opposite function. All right? So here's an example for us to work out with. Also, guys, nice and strong to work out, get our brains working out. I have this angle here. I want to figure out the value of that angle. Now look at this. I have a hypotenuse and an adjacent. So thinking of SOHCAHTOA, which one I'm going to use? I have hypotenuse and adjacent. So I'm going to use cosine. So I know cosine A is equal to, adjacent is 16. That's angle A, 16 over 34. Before we found out the ratio, we said, we just divide this and we found the ratio. Now we're going a bit farther, and we're actually going to find out what the degree is. So now I know what A is, I have to cosine that. So I'm going to have to inverse it. So A is equal to the inverse, 16 all over 34. Okay? And I put that in brackets. So I'm going to do that on my calculator, and I'll show you how to do this. This over a bit here so we can see. I'm going to punch second, and then I'm going to hit cosine. And that's my inverse. Okay? And I'm going to type in 16, and we're going to divide that by 34. And I close my bracket, I hit enter. That's going to give me 61.9 degrees. So I know angle A is equal to 61.9 degrees, and that's it. Alright, now here are some examples for us to really test our strength with and the brain power that we just developed. We have finding A here. Now what do I know for this one? I know the opposite and I know the hypotenuse. So for that one, I'm going to use the sine law in SOHCAHTOA. So I know sine A is equal to my opposite, which is 4, divided by my hypotenuse, which is 6. Now I'm going to have to take the inverse of this. So I get A is equal to sine 1, 4 over 6, which is the same as 2 over 3. So I plug that in my calculator. I'm going to push second sine, because this time is sine, and I'm going to go 4 divided by 6, which is the same as 2 over 3. If you put 2 over 3, same thing. So I'm going to end up getting 42 degrees, because it wants it to the nearest degree. There we go. Let's take a look at the next one here. Okay, so I have 19 and 10. Here's B. Well, 10 is adjacent, right? It connects to B. 19 is the hypotenuse, because it's opposite of the right angle. So that's my hypotenuse. So I'm going to use ka. This is obviously opposite or adjacent over hypotenuse. So I'm going to use cosine. So cos B is equal to 10, my adjacent over my hypotenuse of 19. So I'm going to get B is equal to 10 over 19. So I just plug that into my calculator. Once again, I hit second, and we're looking at cosine, and I want 10 divided by 19. That's going to give me 58 degrees. Okay? Now let's take a look at my last one here in this set. We're looking at C. Well, there's many ways I could solve for C. I know this is 29, I know this is 20, and I know, or 21, and I know this is 20. So we could choose whichever one. I am going to use tan, because we haven't used tan yet. What is tan? Tan is TOA, right? It's opposite 21 over adjacent. So I'm going to go tan C is equal to opposite, so 21 all over the adjacent, which is 20. Because this is opposite and this is the touching one. Okay? Other than the hypotenuse. This is not the adjacent because that's opposite the right angle. So that is not adjacent as the hypotenuse. So I look at this now. Put this in my calculator. I'm going to punch in second tan 21 divided by 20. I get 46.4 degrees, so 46 degrees. Okay? And that's it. Now, let's see if I would have gone cosine. So cosine would have been 20 over 29. Okay, so let's try that one. So I'm going to go second cosine, 20 divided by 29. And look right there. It gave me the exact same value. Okay. Now, let's take a look at my next section here. So now we're going to look at two definitions here. We have angle of elevation and angle of depression. Well, the first one here is an example of angle of elevation. So we're looking from the boat to the helicopter. So how do we find the angle of elevation? Well, I must look at this angle, put in color, right here. Okay? So I go straight horizontal and then straight up to the helicopter, and that gives me my angle of elevation. Alright? Now the next one here is an example of angle of depression. So once again, we're going from the helicopter, looking at the boat. What is this angle of depression of the sight? Well, what I do is I first go horizontal line, right, straight across, and then I go how far from that horizontal line he is looking down. So what is the angle looking down from the horizontal? Where angle of elevation was how far I'm looking up from the horizontal line. We're going from the ship to there. So from your eyesight going across, how far we're looking up. Okay? Now, basically, here's my angle of depression. Here's my angle of elevation. Angle of elevation, in this case, is only the ship looking to the helicopter. Angle of depression is the helicopter looking down to the ship. And we're always going from a horizontal. Alright? We're always going from the horizontal to find that angle. That is a key thing. A lot of times, students look, and it's a little bit wrong, just use my magical marker, and they look at this angle here. And they go straight down like this, and they think that is the angle of depression. And they also will sometimes think that this here is the angle of elevation, which is not correct. Okay, so don't get confused with that. Just remember, our angle of depression is from the horizontal down, and our angle of elevation is from the horizontal up. Because if I look at myself, I'm looking straight across. What is my angle of elevation? I raise my head. So from here to here, that's my angle of elevation to look up to the helicopter. Now I'm in the helicopter, straight across, right? Then how much I move down from here? I move down to there. That is my angle of depression. So I'm looking down to the ship. Okay? So now, let's take a look at some questions here to help you out. So, a tree is 5.1 meters tall. Cast a shadow of 7.5 meters long. Calculate the angle of elevation of the sun to the nearest tenth of a degree. So I want the angle of elevation of the sun. Okay? So first of all, let's take a look at this. My tree, we're going to make a diagram. Okay? Here we go. And I know the shadow is 7.5 meters long. So this is 7.5 meters. This here is going to be a right angle. Alright? And I want to calculate the angle of elevation from the sun. So if I'm trying to find the angle of elevation to the sun, or of the sun, I want this angle here. So from here to the sun's going to be way up there, right? The sun is over here. Happy little sun. Okay? So there's my sun. Now, here's my horizontal, and my vertical is going to be where? Right here, which is 5.1. We know the tree is 5.1 meters. Okay? Now, let's see. What do I know here? I'm trying to find this angle here, which is my x. Well, I know my opposite, and I know my adjacent, so I'm going to use tan. So I know tan x is equal to my opposite, which is 5.1, divided by my adjacent, which is 7.5. Okay? I solve this now. Just need my calculator. And I'm going to go, because we're trying to find the angle, so we have to second tan. Go here. Go second tan. I'm going to go 5.1 divided by 7.5. And I end up getting 34 degrees. 34, and it says to the nearest tenth of a degree, 34.2 degrees. Okay? Let's take a look at my next question. So it says a boat is 130 meters from the base of a cliff. The cliff is 80 meters high. So first we're going to draw a diagram. Okay? Here's my cliff, and my boat is somewhere over here. Okay? So we have the boat is 130 meters. So this is 130. This is going to be 80. Okay? Now we want to know the angle of depression of the boat. So of the boat, we're going from here. So angle of depression, going down. Now notice I needed that horizontal there, don't I? Okay? So I'm trying to find this angle here of depression. Now, let's take a look at this. There's more than one way of calculating this. I'm going to show you the first way right now. So I want to find out this angle here. And if I add these two angles together, that's going to be 90 degrees, right? So let's first figure out if I can find out this A. Now if I look at A, I know the opposite and adjacent. This is my right angle. So that's going to be tan angle A is equal to opposite 130 over adjacent 80. So then A is equal to tan negative 130 over 80. So let's try and solve that. So I'm going to go second tan 130 divided by 80. And I'm going to end up getting 58.39. I'm going to store this as x. I'm going to show you how I'm going to do that. I hit the store button way down here. Okay? And then I'm going to hit this button right here, store as x. So then now whenever I hit x, it's going to give me that angle. So I have 58.4. Okay? So I know this part here is 58.4 degrees. But I want to know this part here. But we know from here to here is 90, right? Because straight across, straight down, that makes a 90-degree angle. So I'm going to go 90, subtract 58.4 will give me 32 degrees approximately. Oh, 31.6 degrees. And it wants to nearest degree, so that's equal to 32 degrees is going to be my answer. Alright? And that's it. Okay, so let's take a look at my last one. We have, consider this following triangle, KLM. Here's my triangle. KL is 20. So KL is going to be 20. LM is 20 centimeters as well. KM is 30 centimeters. Okay? So why can we not use SOHCAHTOA for this KLM? Well, that's because, is this a right angle triangle? It is not a right angle triangle because it's not right angle. Okay? So now it says determine to the nearest measure angle KLM by splitting the triangle KLM into two congruent triangles. So if I split this like this into two congruent triangles, perfectly balanced isosceles triangle, so this is going to be 15, this is going to be 15. Now I have two right triangles. Okay, so I made two congruent triangles, two right triangles, and I want to find this angle here, KLM. So that is K to L to M, which means this angle. I could find half of that angle here, X. How do I do that? I'm going to use my trig ratios. So I have, what do I know here? I know my hypotenuse and I know my adjacent. Okay, or from this one, hypotenuse and opposite. Okay, so I'm going to go sine, because this one is adjacent, sine X is equal to hypotenuse and opposite, 15 over hypotenuse, which is 20. Okay? Now what is that going to give me? Sine, take the inverse, -1, 15 over 20. Put that on my calculator, I go, second, sine 15 divided by 20, and I end up getting 48 degrees. Okay? So that gives me 48.6. Now, that is only this part here. This is 48.6, but I have to double it. So I'm going to multiply this by 2, because I have to add it again, because that's only half of it. So I multiply that by 2, and I'm going to get approximately 97 degrees for my final angle. So angle KLM is equal to 97 degrees. Sorry. All right? So, hopefully you understand that. Good luck as I see you tomorrow and we work on these together as a class.